Welcome, guys. So keep solving our physics GRE. So number 11. Okay, so number 11 is basically the RC circuit. Okay, so I would suggest that although so in general, to solving this question, you need to use the differential equation. However, in usual tests that probably you don't have, if you are not good at the differential equation, then at least you should remember some constant. So for this one, you need to remember the constant is called RC. So basically, you know that the capacitance will start to dissipate the charge to the resistance. So basically, we don't have to solve. Once you know this RC, then you know the answer must be this. So this is the Q on the capacitors for different time t as this formula. So this after closing the switch, how much time is 1/2 of capacitor's initial stored energy? So the capacitance energy is Q squared 2C. So it means that Q equals to Q0 over square root of 2. Okay, then it's easy that Q0 over square root of 2 equals Q0 minus exponential t over RC. So, okay, you take a log. Both sides, you have RC equals to half log 2. So t equals to RC over 2 log 2. So the answer is E. Okay, 12. So if you have some experience solving the Laplace equation, that you know how to solve this. So basically, you have x and y. Basically, there's alpha and the phi is 0. Phi is phi. Phi is phi. And ask you about the so-called potential. Okay. So remember, Laplace formula is this. So, and there's only one parameter, which is phi. So this is this one. Actually, this is not correct, because you need to use the polar coordinate. But it's fine that if you only remember this is enough. So v is just a phi plus b. So plug in the angle, we have v of phi equals to I should write theta. Okay, so the notation looks very bad. I apologize. Okay, so you can see v of 0 is 0, and v of phi, which is phi. Okay. So the answer is B. So theta is phi in this case. The answer is B. If you don't know about the answer that you can plug, you can see the first one does not obey the good boundary condition, and the B is correct. C is not correct. Definitely, you can just use Laplace operator act on C, D, E, and you will see only B and A is 0, and A is not okay. So if you do not know how to solve the Laplace equation, you can just plug the answer and see whether it's okay. So the answer is B. Okay, and 13, I suggest that you mark this question. So common question in the electrodynamics. If you add the magnetic monopole, then which one will be incorrect, or which one need to be modified? So the stupid answer is that this should be modified, because once you have magnetic monopole, then the magnetic field will have source. So this one must be modified. And also, if B is modified, then any theory related to B must be also modified. So this one, the first one, must also be modified. Okay, so sorry about this. So once this one modified, the second one, since we can take curl of E, curl E, and we can take the divergence of curl E, and then this will becomes, this must be 0. But now this is non-zero. So the equation of second, the second equation is inconsistent. Suppose we take divergence on the second equation, then if we assume that divergence of B is non-zero, then the second equation is not consistent. So we need to modify the second and the fourth. So the answer is D. The answer is D. Okay, so the total energy of black body radiation. So you see the temperature increase. He said if the temperature of the black doubled. Okay, so the black body and temperature. What you need to come out is Stephen's law. The power proportional to T to the force. The power proportional to T to the force. This question is very common. Okay, so you see, if the temperature just higher than increase the 0.5, then if you double, then you should times 14. You should times 16, 2 to the fourth. So the temperature increase should be 8. Temperature increase should be 8. So the answer is C, 20 to 28. Okay, 15. Okay, so let me summarize something before going to this question. So ideal gas, there are Cp and Cv, and Cp is equal to Cv plus R. Cv is the heat capacity for the fixed volume process, and this is the isobaric process. For the ideal gas, one is the monatomic, one is the diatomic, and this is general. And Cv is, so one degree of freedom give you 0.5 R. So monatomic, you have 3 translation, so you have 3 over 2 R. Diatomic, you have 3 translation plus 2 rotations, so it's 5 R over 2. And in general, you have 3 translations, 3 rotations. So Cp is Cv plus R. So okay, remember this table. This is very important. So is that all about diatomic and blah, blah, blah. Okay, what is the specific heat at constant volume? Right, so we already write the answer. But so for this one, what we use is the region model. But what you use is there is an oscillation from here to here, oscillation model. So that means is that you can see the question where the double bond is free to rotate and the perpendicular to surface. So basically you have 5 degrees of freedoms. But now when the temperature goes very high, you need to add a vibration mode. So there's 1 R for the vibration. There's 1 R for the vibration. So the answer is C. The answer is C. Why there's vibration? Because there is a spring model here. Okay, 16 said that the energy absorbed temperature is out. Okay, so basically this is the Carnot cycle. So the efficiency is defined to be work over heat extracted from the heat bath, and this is 1 over Tc 1 over Th. Okay, so you have the work. He said that for 200 joules of heat input over work is 1 minus. Remember that you need to, and the cold is 527. The hot is 727 plus 200. So you need to change into Kelvin. Okay, so it's obvious that this is set up very good. Okay. So this is 1000. So 0.2. So W is 400. So the answer is A. And the 7 said that the output of 2 electron oscillators compared to the oscillators. The oscillator started initially at the center of screen. Oscillator Y connected to vertical, and so remember that there is a. He said that if the frequency of oscillation Y is twice the oscillation of X. So what it means is that the total wave should look like sine t plus sine 2t, which is and which one is this plot. So A probably I'm not sure, but B is not correct because B looks like a sine and the C looks like a cosine, sine or cosine. So if this is axis, B should looks like something negative cosine. C is probably is the sine. So what I tell you that is the this function is cannot be written as any sine of ax or cosine bx bt. It's not like that. So B and C is not okay, and D is also not okay because D is not even a function, and also D and E is are just another function for sine t plus sine 2t, which is impossible. So any superposition for sine t and sine 2t will looks like similar to a standard trigonometric function, but not exactly the same. So the answer is A. Okay, 18 in transmitted high frequency coaxial cable, in particular the cable will be determined at the end with characteristic impedance. Oh, this is so-called impedance match. So what you need to prevent is the reflection of the signals. What impedance match is? If two impedances are different, then there will be a reflections, and the signal will be affected. So this is somehow like common sense in the transmission guide, that kind of chapter in the Smith or the Griffiths. Okay, 19 that which is most likely the mass of Earth. So when I see this question in the test, since I remember the answer is 10 more kilogram. So you can, if you remember this, you can remember this. The mass of the Earth is 10 more. So one more is this one. It's 10 more kilograms. Okay, if you remember this, then you can get the answer. But unfortunately, I guess many of you do not know. Okay. So what we can solve is we know this, right? We know that G is equal to Gm over R squared, and we know G is 9.8, but we don't know R, but we know G is this one. I think you use 6 is enough, and we don't know M, and we don't know N. But we know that the R, right? R, the problem already tell us. So R is this one. So we can plug R and solve M. So M is 9.8 divided by 6 times 10 to the 11 times 6 square times 10 to the 12. So which is something times 10 to the 23. And this one is 9.8 times 6. So it's close to 10 to the 24. So the answer is A. The answer is A. Okay. 20. Okay, then 20 is the diffraction, and the reflection. So 1 is okay. Okay, so we have 2. So basically we have double slit interference. Okay, so remember that so this is the formula you need to remember. So the constructive double slit need to satisfy this formula, which m is the integer. This is the double slit. And also, since for each one it has W, and W has some number, it's not so small, so we have single slit. And the single slit result is different from double slit. It is similar, but this is for the destructive, and which n is integer. So what you asking is interference maximum on a distant screen will be missing. So what you mean by missing? What it means is that okay, suppose I did M1 and 2, and if both, so if the constructive double slit meets with the single slit disconstructed, then it will miss. So we have d over omega equals to M1 divided by M2. So this is some rational number. So which one can be the answer? Basically, I guess CDE can be the answer. CDE can be the answer. But so we still have remaining CDE. Then it's hard to determine which one is correct. But remember that in general, your double slit should larger than your middle D should larger than omega, than omega. So there's no reason that omega is equal to 2D or omega is equal to 1.5D. So it doesn't make sense that the single slit is too large. I mean, if the single slit is larger than double slit, then basically these two formula, the single slit formula does not make sense. So the only makes sense answer is D. The only makes sense answer is D. So this kind of question looks I mean, it's hard to you just do the computation. So sometimes you need to. So I don't want to say that, but sometimes you need to use the physics intuition to help you get the answer. Okay, so I think we already solved 10 questions. I think it's enough for today, and I will see you guys in the next video. And be sure to subscribe to my channel.